Experiment 45, a different radius for red. Here I change red to have a radius of 10, and the other colors to have a radius of 20. This means that the red particles can only see other particles in 10 units of radius, while the others can see farther. Check my original PPS video for more detailed description of the primordial particle system. Normally, they all had a radius of 5. The emergent behavior was really fascinating. I get these cellular walls that form in multiple stages of birth, rest, growth, rest, regrowth, and then dying that take many cycles to repeat. If you looked at the behavior and tried to fit a formula to this, I don't think you'd be able to. Watch what happens when I change beta. Going down, 10, 9, 8. If you looked at the behavior and tried to fit a formula to explain or replicate this, you could never do it. This is probably how we're currently trying to figure out our own universe. We are finding little formulas here and there to explain little pieces, but the formulas don't work for everything, and the underlying formula is probably really simple, just like it is in this simulation. I mean, it's the normal PPS system with only changing 2 radius. And I never had seen this before, and it kept me mesmerized for like 30 minutes, even knowing the basic PPS formula. I doubt I could have looked at this lifeform and figured out what to change to make it do this. I just had to experiment. So let's go down to some lower betas. 7, 6, 5, 4, 3, 4. I think I'll stumble on something really neat one day, and that might be just as rich as our own universe. Well, maybe not that rich, but I'll know the underlying formula, and everyone can try to guess what I did. I'll probably throw away a lot of reject simulations that could have spawned neat results if I had only let them run longer or on a bigger playing field. Oh well, such is life. So now let's change beta up and down and see what happens. So we're going to go down to this magic beta I found of 1.65. Let's watch this for a while. So you noticed all these circles that I was getting as I changed beta down. But going back up to 24 beta, I don't get these circles again. They just kind of disappear into oblivion. Here we go. But watch immediately if I bring it down a little, I'll start to get circles. So it's like not only the value of beta matters, but also the direction in which you're changing beta, which is something I never would have expected. So let's go back all the way up to about 17, which is the normal beta value for the PPS system. No circles at all. $11, $12, $13, $14, $15, $16, $17. Now let's go back down. Watch the circles that form pretty immediately. So we're starting to get them here at only 12. Up here. Get even more at 11. And we didn't see any of these on the way back up to 17. This one looks like an eyeball. Here we have the outer eyelids, flesh, and the cornea here. Kind of neat. These things stare back at you sometimes. Beta 9. Seven, 6. This is what I would call a glider in the PPS world. There's a glider in the cellular automaton world that kind of glides across and never changes, but this guy turned into a nucleus instead of a glider. But sometimes you get these little gliders, they look like solar sails. There's a bunch of particles on one side with a nucleus in the middle, and the nucleus kind of follows the outer sail. It's kind of doing it here, where there's more on the outside here and less over here at the bottom. Kind of, this nucleus kind of wants to travel to where there's more in the shell. So we'll go down to 5, 4, 3, and I want to show you what happens at 1.65. And a little bit farther down, I guess. Maybe it was 0.8. Okay. So here, things kind of explode on some denser nucleus. This guy seems to still be holding. But watch what's going to happen to these red particles. Now let me change it so that this nucleus kind of explodes and gets some particles out into the field. And we'll put it back at 0.8 and see what happens. I've got to rupture the cell walls that formed to kind of get it back to a new state. See if I can coax it to get to what I want to show you. This is a very stubborn little creature here. He doesn't want to expand his horizons. Talking about this guy. A robust little life form clinging on to survival. Come on, little guy, you can evolve. You can become something better. So after a little coaxing, I think I got this guy to do what I want. So at beta 0.25, we'll wait till these guys spread out a little. And now we'll bring it back up to 0.8. Look, there it just emerged. Now you notice I didn't see that earlier at 0.8. All I had to do is change the initial conditions. It's like there's a state machine involved with this beta value, and it's not just what the beta value is, it's also where it has been and what the motion of the particles is in their positions. So here you see a very regular hexagonal structure. It's because these red guys have found their steady state where they're in this lowest energy state and they don't want to move. They're perfectly satisfied, and they would require more energy to go into a different state. So let's change it up a little, about 0.9, 1. See, the hexagonal pattern still is intact. But then at 1.6, things get a little chaotic. So let's bring it back down. Point 0.9, 0.7, 0.3, still holding, 0.2, negative. My daughter pointed out that there are hexagonal structures in chemistry, and that's what led me to my next part of the video, gravity, microgravity to be precise. Let me change experiments and I'll be right back.